All right, let's talk about parallel and perpendicular lines. So this is an equation of a line. If I asked you to make a parallel line that goes through this point, parallel lines have exactly the same slope. So by telling you I want it to look like this one and be parallel, I right now know that this is the slope. What I'm missing is B. I'm missing B. So what I'm going to do is plug in 6, 3, because I want something that's parallel to the original line, but goes through this point. So I'm going to plug in this. So it's going to be y equals, not y, it's going to be 3. I don't know why I didn't plug it in. 3 equals negative 1/3. X is going to be 6 plus b. I'm going to multiply 6 times 1, or 6 times negative 1. That's going to be negative 6 divided by 3. That's going to be negative 2 plus b. I'm going to add 2 to both sides. Sorry, I was thinking of the answer already. 5 equals b. So 5 equals b. So now that I know what b is, and I know what the slope is, I can write the equation in its entirety. 1/3 x plus 5. And that's it. So what if I asked you to make an equation that is perpendicular to this line, but goes through these two points? So now I need the perpendicular slope, which is the opposite reciprocal. So not only is it going to be positive, it's going to flip and become 3/1, which is really just 3. So the slope for this one is 3x, or 3. And I still do not know what b is in this one. So I'm going to plug in 6 and 3. 3 equals 3 times 6 plus b. So that's going to be 3 equals 18 plus b. I'm going to subtract 18 on both sides. And I'm going to get negative 15 equals b. So now I know b, and I know the slope. So my final answer is that. All right, so let's do domain and range. Domain is all possible x's, and range is all possible y's. This is an example of a continuous graph, because it continuously connects 2 points, or at least is continuously going. This is not continuous, this is discrete. So let's do the domain, and I'm going to write it in set builder notation. So the domain is going to be x, this line here. So the lowest x, so these are x's. So the lowest one would be here. This is as low as it goes, and that's negative 1. So it's going to be from negative 1 all the way to, let me see here, 0, 1, 3 is as far as it goes. So it's going to be 3. All right, now let's check this one out. This is going to be, we forgot to do the range here, so this is the range. The range is going to be all possible y's, so we're doing y's now. And what's the lowest y? The lowest y is going to be negative 4, because that's the y. And the highest y is 0. And now I have encompassed all of the coordinates. Now here is discrete. So the domain actually only consists of 0, 1, 2, 3. So the domain consists of all the integers. So all integers from, you can write whole numbers here, but I just like to write integers, from 0 all the way to 3. And then the range is from 2 to 4. Same thing, integers, because it doesn't skip any numbers. So y is going to be all integers. could write whole numbers in this scenario. I just like writing integers. And it's going to be 2y all the way to 5. And that's domain and range for continuous and discrete. Then let's talk about a function. A function, for every x, there's exactly one y. So this is the original function. Remember, it's the same thing, just we're replacing y with f of x. So I wanted to know what the answer would be if I wrote f of 8. So f of 8, so if you can notice, the x was here, but now the 8 is here, which means all x's are being replaced with 8. So 8 times 1 divided by 2, that's going to be 4. And then that's going to be 9. So f of 8 equals 9. And that's a function.